Greetings, welcome to Self-Assessment Lesson 10, Problem 3. So complete the table. Write intercepts as ordered pairs. Use inequality notation for the domain. Round to the nearest hundredth as needed. Write n if the answer does not exist. And I think what they mean there is does not exist in the reals, because many times the answer will exist, but only in the complex numbers. Okay, so just a quick review here before we get started on this. Let's say we have the nth root of a, and in this case we know that n is even. In other words, we have an even index, okay? So if that is the case, then a has to be greater than or equal to 0 to be real. If it's not, then we end up with a complex number. And we're just really not prepared to deal with that at this point, okay? On the other hand, so that's case 1. Case 2 is n is odd. So if n is odd, then a can be any real number. Little sideways e there means an element of the reals. It can be anybody, and it does not have to be greater than or equal to 0. Only when n is even, okay? All right, keep that in mind. That's going to come in handy here in a bit when we start talking about domains. But in the meantime, let's get that out of our way. All right, let's go take a look at the questions that they want from us. So the first one is they want to know what is the vertical intercept of f of x equal to the fourth root of 8x. So key thing, of course, again to remember is that when we're talking about a vertical intercept, what we're really talking about is a y-intercept, which is the vertical axis, and that infers to us that x has to be equal to 0. So when you want to find a vertical or y-intercept, you need to evaluate f of 0. So f of 0 equal to the fourth root of 8 times 0 is going to give us the fourth root of 0, right? And the fourth root of 0 is equal to 0. So that tells us that the vertical intercept here is actually the origin at 0, 0. Okay, let's do that again, but this time let's do it for f of x is equal to x minus 3. And I'll switch colors on here to try and keep them separate. We'll make this one the blue one, okay? And we'll make this one the black one, and we'll make this crazy one the red one. All right, it's a little color coding. Hopefully I'll remember to keep that going, but I'll do my best. Okay, so f of 0 is equal to the cube root of 3 minus 0, not cube root, square root, excuse me. And so that's going to evaluate to just the square root of 3. So that tells me that the ordered pair that corresponds to the vertical intercept on this particular problem is going to be at 0 by square root of 3. Okay, and now for our last competing number f of x. He's at f of 0 again, and this time we are doing a cube root. And we've got the cube root of 0 plus 8, which gives us the cube root of 8, which is equal to 2, because 2 times 2 times 2 gives me back 8, and so we know that that one is at 0 by 2. Okay, cool beans. All right, so we now have all of our vertical intercepts, or our y-intercepts. Let's get that sheet clean over here. And now we want, but of course, the horizontal intercept. Okay, so the horizontal intercept, that's going to be the x-intercept. So the horizontal int, or the horizontal intercept, that infers to us that we're talking about the x-intercept. And if we're talking about the x-intercept, that must have meant that y was equal to 0. Or, more importantly, f of x is equal to 0. We're working in function notation. So to find the x-intercept, you set f of x equal to 0. So that tells me in my first one, I've got 0 is equal to the fourth root of 8x. Well, how do I solve that? Well, let's raise both sides to the fourth power. And we get 0 is equal to 8x, which says that 0 is equal to x. And you go, well, duh, because I had my intercept for my vertical intercept was 0, 0, so my horizontal intercept is also going to be at 0, 0. All right, cool. So we got that. Well, let's switch over to blue. And now we've got, excuse me, we now have that 0 is equal to the square root of 3 minus x. Again, how do I get rid of that square root? We're going to square both sides here. And if I square both sides here, I get back 0 is equal to 3 minus x, or I get back x is equal to 3. So that tells me that this one is at 3 comma 0. All right, last but not least, let's go do the red one. And so we've got 0 is equal to the cube root of x plus 8. So let's go ahead and cube both sides of this. Got a little extravagant with my radical symbol there. Got a nice long tail. So I end up cubing both sides and I get 0 is equal to x plus 8, which hopefully you can see leads me to negative 8 is equal to x. So that tells me negative 8 by 0 is the horizontal intercept on that one. All right, cool. Got half of it done. So let's go pick up the other half. So now they want us to go find the domain. All right, so let me repeat one more time what I said at the start here, because that's going to be very helpful for us figuring out what the domain is. So if you have the nth root of a, there are two cases. The first case is n is even. And if n is even, then what you know is that a has got to be greater than or equal to 0 in order for that to be real. Okay, it'll still be defined, but it's just not defined in the reals anymore. The second one is n is odd. And if n is odd, then a can be any stinking number you want it to be. It can be any real number. Okay? All right, so that's going to help us back here with the domain, because on the first f of x, we've got the fourth root of 8x. And so what that tells us is that a, which is equal to our 8x this time, has got to be greater than or equal to 0. In other words, 8x has to be greater than or equal to 0, or x has to be greater than or equal to 0 if I divide both sides through by 8. So they asked us to use inequality notation to define our domains. So that is the set of x's such that x is greater than or equal to 0. So as long as I keep my x's bigger than 0, I'm going to be in the ballpark. Okay, let's go switch over to blue and let's go do the square root of 3 minus x. So in this case, again, what we've got is we've got the square root of a, if you want to think about that. And so a has got to be greater than or equal to 0. In other words, 3 minus x, what is underneath the square root, this piece right here, the thing that's under the radical, that's got to be greater than or equal to 0. Or 3 has got to be greater than or equal to x. Or probably an easier way to think about it is x has to be less than or equal to 3. So that tells me that it's going to be the set of x's such that x is less than or equal to 3. Okay, and last but not least, we have an odd indexed root. And if it's an odd indexed root, I don't need to do any work whatsoever. I just need to look at it and go, well, it's all reals. So I can state that in words. I can say all reals. Or if you want to be a lazy mathematician, you can just put down this symbol. The script R means all reals. Okay, last but not least, they're going to ask us to do a little bit of work with these functions. In particular, they want us to evaluate the function at 5. So we're going to take each one of our f's and evaluate them at 5. So working in the black now, in other words, working with f of x is equal to the fourth root of 8x, we get f of 5 is equal to the fourth root of 8 times 5, which gives me back the fourth root of 40. And so what I'm going to have to do is go plug that into my calculator, and they say take it out to the nearest hundredth. Okay, so let's go do that on the calculator here. So I'm going to go 4, I'm going to go math, I'm going to go grab option number 5, and so I'm putting in the fourth root of 40. If you're on an old calculator, then you need to make sure you close the parentheses before you hit enter. If you're on one of the newer ones, it'll pull the line across for you. hit an enter, and we get 2.5148, etc., etc. They said to the nearest hundredth, so the hundredth, that's 2 decimal places. So we only need to go out to 2.51. So that says that f of 5 is approximately 2.51. Okay, so let's go do the blue problem. So let's go take a look at what 5 would be in this one. Okay, so we have f of 5 is equal to the square root of 3 minus 5, which gets me the square root of -2, and you go, that's not working for me. Okay, in particular, hopefully we would have seen that because we know our x's had to be less than or equal to 3, and we put a number bigger than 3 into there, so we were out of the domain, so that does not exist. So they say write an n in here, but how about you put in nar for not a real? So it does exist, it just doesn't exist in the real numbers. So it does not exist in the reals. Get it together, guys. It's not real. Okay, one last one. We're going to switch back over to the red pen here. And we've got what? F of 5. And we're plugging that into the cube root. So I can make myself a nice cube root here. There we go. Of 5 plus 8. So I put in the 5 plus the 8. Okay, and so that is going to give me the cube root of 13. So we'll have to go consult the oracle for that, go see what the calculator tells us. So we're going to go into math, go to option number 4 for the cube rooter, and put in a 13. Again, if you're on an old school calculator, close off that parenthesis before you hit enter. And we get 2.35, etc. So this is approximately 2.35. So in the red column, f of 5 is approximately 2.35. Okay, well, hopefully that answered any questions you might have had about this one. If not, do not be shy about posting things to the Q&A forum, or you can send me a message directly.